Math 1314, review, standard normal distribution, Z. Video 4, the standard normal distribution table. In other words, the Z chart. Before we go over what the Z chart is, I want to remind you where to find it. If you go into Canvas, and we'll do the student view. So it looks like what it looks like when you log in. Then that doesn't look like a student view. There we go. That's better. Then there are already PDFs of the Z distribution, the T distribution, and whatnot. You can find them a couple of ways. You can go into announcements, and there's an announcement for some distribution tables you might want to print. You can also access these by clicking Files and then clicking on the Distribution Tables folder. But let's go ahead and click the Z distribution, and I'm going to download it so that it's in its separate tab in this browser. You might want to print this out. If you do, and you have the option, print it two-sided, because it is a two-page document. On one side are the negative z-scores, and on the right side are the positive z-scores. But before we go roaming through this collection of numbers, let's just figure out exactly what's going on here. Let's see. Oh, I need to do a screen share. That's what I need to do. Or there we go. All right. In the Z chart, the numbers on the left column in the top row measure a z-score. Let me show you what I'm talking about. There are numbers, first off, you'll see a Z in the upper left-hand corner, but it's measured going downwards and to the right. The numbers in the left column and the numbers on the top together determine a z-score accurate to 2 decimal places. Specifically, the number in the left column gives you the 1s and 10ths TH digits of the z-score. In other words, it gives you the number to the left of the decimal and the number to the right of the decimal. The number in the top row gives the 100ths digit of the z-score, so it gives you the second decimal place. So let's go back to the Z chart and show you what I mean. If we were to look at this row, then we are looking at a row whose z-score starts with -2.8. And then when we pick a column like this one, notice it says 0.00. That's because this thing's getting all kinds of goofy. Let's zoom in a little bit. When it says something like 0.03, what it's saying is, don't worry about the first 2 digits. We've got that covered from the row that you select, but the next digit's going to be a 3. So if I were to look at this number in the Z chart, because it's in the -2.8 row and the 0.03 column, the z-score we're looking at is -2.83. So again, when you see something like -2.83, these two numbers are found in the left column, whereas this number is found in the top row. So a z-score accurate to 2 decimal places can determine a row and a column to look up. At the intersection of the given row and column, you will find a 4-digit decimal. This decimal is the area under the standard normal distribution given, this decimal is the area under the standard normal distribution curve. Have no idea why the word give is there. That's better. To the left of the z-score. Before we go back and look up that 4-digit decimal in the -2.8 row and the 3 column, and I want to clarify that when I wrote left column here, what I'm saying is you look in the left column to determine the row. And when I wrote top row, I mean you look in the top row to determine the column. All right, but regardless, the number that you look up in the middle represents the left area. So if I were to draw a standard normal distribution curve, and which has 0 in the middle by definition. And we look at z equals negative 2.83 right here, then this area to the left is located inside of the z table. Let's go back to the z table for a second. The negative 2.8 row is here. So somewhere in here is that area that we shaded in. But the second decimal digit was 3. So we look in the 0.03 column, and the intersection of this column and that row is 0.023. That means that this area is 0.0023. So in context of probability, that means the probability that z is less than negative 2.83, if you have a standard normal distribution, is 0.0023. Fairly small probability. As a percent, it's even less than 1%. So let's do a few examples and show how to make modifications when we're not necessarily looking at left areas. Find the area to the curve, find the area to the left of z equals 1.28 under a standard normal distribution curve. Word of advice from me to you, and on your test, I'm going to be looking for this. On any problem with the bell curve and an associated area, I will explicitly tell you to draw the bell curve and shade in the correct area. In this case, being a standard normal distribution at center is 0. Z equals 1.28 is over here. If I shoot up from there to the curve and shade in to the left, since I did ask for the left area. And it doesn't have to be completely shaded in, but put a little bit of effort in. If I ask you to shade something, I'm literally giving you points for coloring. Do it. Okay, that's good enough. If we want to find the area to the left of that, our Z chart tells us left areas. All we have to do is locate the correct row based on the 1.28, the correct column the correct row based on the 1.2, the correct column based on the 8, and the intersection will tell us that left area. I invite you to get your Z chart out or get a hold of one real quick, even if it's online, see if you can find this answer. I will tell you that on the first page are negative Z values. You can tell by the negatives in the leftmost column. So we have to go to the second page for positive Z values. We want 1.28. Now, if you're scrolling down, you might lose the top row. Just remember that if you can't see the top row, like if I'm down here somewhere, they don't start with 1, they start with 0. So if you're going to count from left to right, be sure you start counting with 0. For example, we want 1.28. Here's the 1.2 row. 1.20, 1, 2, 3, 4, 5, 6, 7, and 8. So it's actually this number here, which is in the 0.08 column. If you check, it's actually the 9th column. That's because the first column is labeled with 0. But regardless, the intersection of the desired row, the 1.2 row, and the desired column, the 0.08 column, there's a 4-digit decimal, 0.8997. What that means is that this area is 0.8997, or at least I believe that's what it was. Yes, it was. So as an area problem, it's over, but I do want to remind you that this also tells us a probability that gives us the probability that Z, because that's the variable for a standard normal distribution, is less than 1.28 is 0.8997. So almost 90% chance that in a standard normal distribution, if you pick a number at random, it's going to be less than 1.28. We could also say less than or equal to, but I'm not worried about that. All right, so left areas are pretty easy. You look up the Z-score in your Z-chart, and the intersection of the correct row and column gives you that left area. But what if it's not a left area? Because the Z-chart only gives left areas, this is supposed to be covered. So can y'all just pretend for a moment that you didn't see that? All right, because the Z-chart only gives left areas, we have to make an accommodation to find right areas. Since the total area under the standard normal distribution curve is 1, We know for any z-score, the sum of the left area and right area, the sum of the left and right areas equals 1. Thus, to find the right area for a given z-score, we look up the z-score's left area and subtract from 1. I just want to give you a real quick visual for this. If we have a z-score and our z table can tell us this area, but we want to know that area, well, the total of those is equal to 1. So we can look up the pink area, the left area in the z chart, and subtract it from 1 to get the green area, the area to the right. And that is a bad looking z. Oh, I don't think I've said this yet, but just as a note, when I write my z's, I know they normally look like that, but I always put a line through them to distinguish them from the number 2. All right, so in other words, there's something down here to look under. Where'd it go? Did I get rid of the words? I guess I accidentally got rid of the words. All right, so I'll just type it again. That's funny. All right, so in other words, right area equals 1 minus left area. There's actually another way to get a right area out of the chart. I invite you to think about it, but we're just going to focus on the one technique that the right area is equal to 1 minus the left area. So let's use that to find the area to the right of z equals negative 2.04 under a standard normal distribution curve. You should always, always, always draw a bell curve when you're talking about areas because you're going to shade them in. 0's in the middle in a standard normal distribution. Negative 2.04 is over here somewhere. That's a z-score, so we'll write z equals. We want the area to the right, so I'm going to shade that in. Let's use yellow. Now, one thing I meant to mention in the previous example, but I didn't, so we'll do it now. If you draw this picture, you can go ahead and get an idea of what the answer might be like in relative to the center of the curve. If we cut this curve in half, there's exactly 50% of the area on each side. Do you expect the yellow area to be greater than 50% or less than 50%? It should be greater than 50% because the part over here is already half. That's going to make it more. So by just thinking to yourself, should I get more than 50% or less than 50%? That helps you avoid some errors, especially when you're doing right areas. Let's look up this left area by going right to the z chart for negative 2.04. Oh, by the way, I will provide the z chart on all of your tests as necessary. Negative 2.04. So we go to the negative 2.0 row, which is here. And then we go under the 0.04 column. Now, if I scroll up, you'll see that it's this column here. But even if you didn't scroll up, you could just count from left to right. Just make sure you start counting with 0. Negative 2.00, 1, 2, 3, and 4. This should be the correct one. It is definitely in the negative 2.0 row. And if I scroll up, it is in the 0.04 column. That number is 0.0207. Let's go back to here. Our left area is 0.0207. Now, if you weren't paying attention, you might say that this is your answer. But remember what we said a minute ago, that the answer should be more than 50%. If you've already thought that before looking up the number and you see this, your brain's going to go, that's not big enough. It's supposed to be more than 50%. Well, that's because we're not done. The right area is equal to 1 minus that. And if you do that subtraction, you'll get 0.9793. So it was more than 50%. In fact, it's pretty close to 100%. I also want to remind you that you could interpret this as a probability by saying the probability that z is greater than negative 2.04 is 0.9793. Very unlikely. In fact, it would be unusual if this wouldn't happen. All right, so for right area, it's 1 minus the left area. One other type of area problem. To find the area between two z-scores, look up each z-score's left area, then subtract. I want to kind of give a reason for this. Let's say we have a couple of z-scores. We'll just call this one A and we'll call this one B. And our area of interest is in the middle, right here. The only thing we can look up directly in the z-chart are left areas. So let's think about what we would find if we looked up each z-score's left area. If we looked up the left area for A, it would give us this over here. If we looked up the left area for B, it would give us all this. So what we want is the pink part shaded in the middle. If we look up B, it's the part surrounded by blue, which includes what we want, but it also includes some parts that we don't want, namely the part to the left of A. If we look up the area to the left of A, that tells us how much we don't want from the area to the left of B. So it makes sense that the area surrounded by blue minus the area surrounded in what's supposed to be red will give us the pink area in the middle. So look them up both and then subtract them. All right, so let's find the area between these. Let's draw the picture first. Get used to drawing these bell curves in my class. You'll draw them on a majority of the problems as we go through the class. What's in the middle of a standard normal distribution? 0. I ask you that because both of these z-scores are negative and hence both will be over here somewhere. Negative 0.93. Negative 0.38. We want to know the area in between. And so we just look up both left areas. Let's start with negative 0.93. In fact, let me go ahead and start typing this. Area to the left of z equals negative 0.93 is, all right, let's go look it up. Negative 0.93. It's way down here. Here's the negative 0.9 row, and let's go to the O3 column. Remember to start counting with 0. Negative 0.90, 1, 2, 3. Looks like we got 1762. Sorry for the pause. I had a whiny dog, had to go check on him. We were finding the area to the left of negative 0.93, and it is currently shaded as 0.1762. 0.1762. But we also need to know the area to the left of the other z-score, negative 0.38, and so let's go look up that one. Negative 0.38. Negative 0.3. And 8 is easy because the last column is 9, so we just have to back it up 1. So there's 9 and here's 8. And if you're not sure, especially if you're looking at the PDF, scroll to the top to make sure. That is the 0.08 column. This is the correct row, negative 0.3. And so the area to the left of that is 0.3520. 0.35, was it 2 or 8? 2. All right, so now that we know the area to the left of both of these z-scores, so the area in between is the difference, 0.3520 minus 0.1762. That's equal to something. I'll cheat and use my calculator. Okay, it's not cheating. 3520 minus 1762. And by the way, I didn't type any of the decimals. I just know it's a 4-digit decimal answer, 0.1758. So that's how you find an area in between. I want to check something real quick. Okay, I did do the probability and comparison there. I did the probability there. So what would the corresponding probability be here? I think I'll type this one. This means that in a standard normal distribution, I can spell really well. I just can't type worth anything. The probability that our leftmost z-score was negative 0.93, the probability that that is less than z, which is simultaneously less than negative 0.38, is 0.1758. Now you may be wondering, why are we doing all these probabilities? Because when we estimate values, we want to estimate it with a certain confidence level, but that confidence level translates to a probability, which translates to an area under a curve. And when we do hypothesis testing, we need to know the probability of an event occurring, which translates to an area, which can be found in the Z distribution table or any other distribution table that we may use.